Hi friends, welcome to GMK tutorials. So today we are going to discussing about the operational amplifiers, that is nothing but inverting and non-inverting concepts. So before entering into the topic, we have to discuss some of the important points. So we know that generally in case of the ideal operational amplifiers, ideal op amp input resistance Ri is equal to infinite. So the input impedance is nothing but input impedance is infinite, means that it does not allow any currents inside the operational amplifier. So that is one of the most important point. So let us see. This is operational amplifier circuit. I will call this a I1, I2. Okay. So because of the infinite input impedance, it does not allow any currents inside the operational amplifier. So the voltage terminals is equal. Okay. So next point is nothing but generally we know that in case of the ideal characteristics, open loop gain. Okay. Open loop gain is infinity. That means AV is equal to voltage gain. AV is equal to output voltage by, so here input voltage. So input voltage means generally in case of the operation amplifier, VI means that V2 minus V1, that is also we can call as a V0 is equal to VD. So D is nothing but difference voltage. Okay, VD is equal to difference voltage, right? Suppose if the open loop criteria, if you want to satisfy this condition, open loop gain infinity D, so VD must be 0, then only A open loop voltage is equal to V naught by 0, that is nothing but infinity. So if you want to satisfy this condition, compulsory VD value is equal to 0. So VD value means 0 means that V1 minus or V2 minus V1, okay, is equal to 0. Therefore it implies that V1 is equal to V2. That means both terminals are at equal potential. So because of the infinite voltage gain, this is generally called as a virtually short. Okay, this concept is called as a virtual short concept. Okay, okay, virtual short. Okay, so this is one of the most important point. Okay, so coming to the inverting amplifier, inverting amplifier. So let us see the circuit diagram for inverting amplifier. Inverting amplifier. Let us see the circuit diagram for this one. I will call it a VI. So input voltage VI. This resistance is nothing but a source resistance. I have to use some feedback resistance. Okay, I will treat output voltage as a V naught. Okay, plus V and minus VE. So this is some of the voltage representation format, and it is a negative terminal. Okay, this is a negative terminal. This is nothing but positive terminal. So positive terminal is a grounded. It is a source resistance. Okay, so this is a current entering into the current I1. So I will call this current as a I2. Okay, this point I will treat as a, okay. So this is the concept. Now, so we know that generally where a non-inverting terminal, where non-inverting terminal at zero potential. So this is zero. This is also zero. So from this we can write the KCL equation. Apply the node at this point. Okay. Apply the node at this point at a KCL. Okay. I will at this point. Okay. Therefore, input resistance Vi minus 0 by Rs is a source resistance plus V naught minus 0 by feedback resistance can be treated as a RF. Okay, this resistance can be represented as a RF because of it is a feedback resistance RF. It's equal to 0. Okay, so from this, what we are going to represent Vi by Rs plus V naught by Rf is equal to 0. So our aim is to find the voltage gain for the non-inverting amplifier. So voltage gain, if you want to find out the voltage gain, V naught by Vn is a final equation, right? So for that purpose, okay, therefore V naught by Rf is equal to minus input voltage by Rs, source resistance. Therefore V naught by Vi is equal to minus Rf by Rs. V naught by Vi is nothing but generally called as a voltage gain. Okay. Therefore, V naught by Vi is a voltage gain in case of the inverting amplifier. Right. Now, if you want to find out the only output voltage, V naught is equal to, how can I represent? V naught is equal to minus Vi into Rf by Rs. Okay, this is the equation for the non this is the equation for the inverting amplifier. So let us see here, if you observe the corresponding equation, voltage across the feedback path is called as a output voltage. Non-inverting terminal is connected to the ground. Okay, so from this we can also conclude some of the points. That is nothing but, let us see here. So this is the equation, right? So from this equation, output voltage is multiplication of the input voltage and Rf by Rs. Okay. Now, if you observe this one, output voltage is equal minus Va. That means the output signal is produces a out of phase to the input signal. Okay. In case of inverting op amp, output voltage is out of phase. to input signal. So this is regarding the inverting amplifier, right? I hope this video is very helpful for you. Okay, thank you for watching GMK tutorials. Okay, so if you want to conclude, virtual short circuit is the most important point you have to remember for each and every analysis point of view. That is also very important consideration. Okay, moreover, inverting and in case of the negative feedback, we have to take some of the assumptions. Okay, inverting and non-inverting nodes are virtually short circuited and the input currents for op amp are zero. That is two important considerations if you want to analyze the negative feedback and inverting amplifier cases. Okay, thank you for watching GMK tutorials. Thank you a lot.